Hey guys, welcome to the last lesson of the Unit 7 on polynomials. We are in Lesson 6, Special Products. These are products which you have, product meaning times, special meaning special? Shortcuts. Today is shortcut day. Yay! So that's very exciting. So what we're going to do is we're going to show you a shortcut to the shortcut. Remember FOIL itself was a shortcut? I'm going to show you them now. I'm going to show you 3 shortcuts. So we're going to start by foiling out these guys. Now look at these 2 products. Look, we have A plus B times A plus B. When you have a binomial times itself, this is the same thing as A plus B squared. Okay, so we're going to FOIL that out to figure out what we get. That's so cool. All right, so let's look at our first. First, we get A times A. Outside, we get A times B. Sorry, that was supposed to be a plus. What happened? Why is my eraser so huge? Okay, anyway, A plus B. Inside, last. Remember, A times A is A squared. A times B is AB. B times A, I'm going to write them in alphabetical order if that's okay with you. And then B times B is B squared. We're almost done. Look, we have 2 AB terms. So AB plus AB. If you have 2 of them, that's 2AB. So our final answer here is A squared plus 2AB plus B squared. So if you have something, you know what, I should have done this in a different color. Haha. Okay, there you go. Check that out. That was so cool. So if you have A plus B squared, that's equal to A squared plus 2AB plus B squared. That's our first shortcut of the day. Sweet. Now let's look at our second example. We're still going to FOIL out again. This time we have A plus, sorry, not A plus B. We have A minus B times A minus B, which is going to give us A minus B times itself. So A minus B squared. Well, let's FOIL it out. What do we get? First, we get A times A, which is A squared. Outside, we get A times negative B. A times a negative B plus negative B times A. And then negative B times negative B. Ooh, that's exciting. Negative B times negative B. Let's simplify this. A squared. Cool. Gives us a minus AB minus AB. Negative times a negative is a positive B squared. And check it out. We have 2 negative ABs. So that's 2 negative ABs. So our final answer here is A squared minus 2AB plus B squared. So if you have A squared, sorry, not A squared minus B squared, that's different. If you have A minus B, that whole thing squared, you still have an A squared, and you have a B squared, and they're still positive. The only difference is you have minus 2AB. Isn't that so fun? So that's so similar to the one we just did, except the only difference is the sign. Here, we had a plus B, so these are all pluses. Here, we had a minus B. So the first one is a minus, but squares are always positive, so that's always going to be positive. Great, huh? Yay. Oh, I didn't like circle it or something because that was a good final answer. Okay, we've got one more. So we had 2 pluses, then we had 2 minuses. What happens if we have one of each? I don't know. Let's find out, shall we? Okay, first, a times a, you know that's a squared. A times negative b. A times negative b. And then b times a. And then b times negative b. Let's clean that up. A squared is a squared. That's great. Plus a times negative b is negative ab. ba, I'm going to just write in alphabetical order. ab. And then b times negative b is negative b squared. Oh, but guys, check it out. What do we have here? We have a plus ab and a minus ab. Those guys are going to cancel out. See you later, alligator. Left us with just a squared minus b squared. Oh, that's it. Oh, my word. Check us out, you guys. We just found like the coolest shortcut ever. It has a special name and everything. If you have a plus b times a minus b, that's too similar, times a minus b. So a plus b times a minus b, that's a squared minus b squared. That's so fun because those middle terms, they cancel out. Just like a plus and a minus cancel out. That's great. Bink, bonk. A plus b times a minus b equals a squared minus b squared. That's our whole lesson in a nutshell. Now I'm going to give these guys names, give you an example, and we'll call it a day. Okay, the squared sums formula is this guy right here. It's what happens when you square, you take this square of a sum. So a plus b squared is a squared plus 2ab plus b squared. For example, we don't have to do all the foiling anymore. We can just plug it in. So looking at this guy, do we have something of the shape a plus b squared? We do. Here our a is x, our b is 4. So we're going to plug those in. That gives us x plus 4 squared equals x squared plus 2 times x times 4 plus 4 squared. See how every time we have an a, we replace that with an x. Every time we have a b, we replace that with a b. Super, clean it up. X squared plus 8x plus 16. That's it. That's our whole answer. We're done. Cool, huh? Let's do another one. Look, we have something of the pattern. A squared, a plus b, quantity squared. Here, our a is 3m, so every single time we have an a, I'm going to put a little 3m there. So 3m squared, 3m. And every time we have a b, I'm going to replace that with an n. That's n plus n squared. Now be very, very careful, because this square applies to both of these guys. So 3 squared is 9, m squared is m squared. Then we just need to combine all these guys. 2 times 3 is 6, m times n we can't simplify, and n squared is all set. Cool, huh? That's our first shortcut. Sums of squares or squared sums, because you have a plus. The next is squared differences, which is this guy. It says, hey, if you have a subtraction squared, you need to follow this pattern. Okay? So we have this minus guy right here, boom, boom, and then a plus. So let's follow this pattern. See how this 4x minus 3 squared fits this pattern? Let's figure out what our a is. Here, our a is 4x. So wherever we have an a, we're going to replace that with 4x. So that gives us 4x, that whole thing squared, minus 2 times 4x times whatever our b is, plus, oh, sorry, I don't want to b squared. Notice it's a minus b, so our b here is 3. So So wherever we have a 3, I'm putting a 3 right there. 3 for b. Wherever we have a b, we get a 3. Okay, 4x squared. Again, we need to take this squared, distribute him to both guys. 4 squared is 16. X squared is x squared. 2 times 4 times 3 is 8 times 3, which is 24. And 3 squared is 9. Cool. And then finally, the difference of squares formula. We get the difference of squares not because of what we start with. Here we started with a difference that was squared. And here we have a sum that is squared. But we end with the difference of 2 square numbers. So this is unique in that sense. But this is what the difference of squares says. If you have 2 numbers multiplied times each other, but one is a plus guy and the other one is a minus guy, then you can just take their squares and minus them. So let's see, do we fit this pattern right here? We do. What is our a here? Here our a is x, and our b is 3. So whenever we have an a, we're going to plug in an x. Wherever we have a b, we're going to plug in a 3. So it gives us x squared minus 3 squared. Well, x squared we can't simplify. 3 squared is 9. There. So x plus 3 times x minus 3 is just x squared minus 9. If you want to FOIL it out, you can, but this is a shortcut. Let's do another one. Does this match this pattern? Uh-oh, it does not match this pattern. But that's okay, because guess what, guys? Multiplication is commutative. So just like 2 times 3 is the same thing as 3 times 2, we can arrange these guys. So that's what I'm doing. Oh, look, it worked. Ta-da. Okay, what's our A? Here our A is 5m. And what is our B? Here our B is going to be 6n. So since our A term is 5m, we'll find out what is 5m quantity squared. Since our B was 6n, we want to find out what is 6n quantity squared. Well, we got to take our square and distribute to both guys in the parentheses. 5 squared is 25, m squared is, m squared. 6 squared is 36, n squared is n squared. There you have it. That's our shortcut. Okay, cool. But why? How come? Well, let's do this to do some quick biology. So let's say you have a population where a parent has a 10% chance of passing the gene for brown eyes to its offspring. If an offspring receives one eye color gene from its mom and another from its dad, what's the probability it will receive one gene for brown eyes? Well, there's a 10% chance, we know, of passing the gene for brown eyes. Therefore, there's a 90% chance for not passing on the gene, right? Because 100% minus 10% is 90%. So let's say if you do get brown eyes, we'll call that big B. And let's say if you don't get brown eyes, that's little b. So let's look at our model down here. Okay. Let's say that dad can have either brown eyes, and that's, or sorry, of getting brown eyes, let's say 10% chance. And of not brown eyes, that's a not 10%, which is 90%. Same thing from mom. You can get the 10% chance from mom, or you can get the 90% chance of not having brown eyes. Well, in order to find their probabilities, we need to multiply them together. So the chance of getting brown eyes and brown eyes is 0.1 times 0.1. Well, that comes out to 0.01, which is a 1% chance. Oof. Of getting brown eyes. Yikes. Okay, well, what's the probability of getting one from your parent, one from just your father? Well, that's 0.1 times 0.9, which comes out to 0.09, which is 9% chance. Here, maybe I should have color-coded these for you guys. Okay, brown and not brown. How about blue? Okay, brown, every time you inherit brown, that's 0.1, 10% chance. Every time you don't get the gene for brown eyes, that's 0.9. Cool. Spoiler alert, this guy is going to be the same here because we have a brown and a not brown. Okay, now the probability of getting 2 not brown genes is 0.9 times 0.9, which comes out to 0.81, which is an 81% chance of not getting brown. So here, since we have brown, I don't even remember where I was going with this. Oh yeah, we need, finally, since these all have brown in them, we need to add them all up. We get 1 plus 9 plus 9 is 19%. Cool, huh? Alright. Well, there you go. That's how we use this in biology. Remember your shortcuts. They're all right here. That's a nice fun place to have them. Oh, I didn't color code this one. Oh well, too late. Hey, have a great time in your homework.